We have just looked at the OSI model in session 3, and in this session, session 4, we want to have a high-level overview of what happens when data is being transmitted or transferred over the network. So the concept of a client-server network or a client-server architecture becomes important, because there are going to be some devices on the network that we are going to classify as being clients, and there are going to be some devices on the network that we are going to classify as being servers. And the distinction between a client and a server is that a client is going to make a request for some resource that the server has, and the server is going to try and satisfy the request to the client by sending over that resource to the client. In our example, we have a PC that is making use of a browser. And in terms of making use of the browser, we want to use the browser to send information. To request information. And the information that is being requested happens to be this image that is placed over on this side. So what we are saying here is that the server has this image and we want that image. So we are going to navigate to the server, get that image, and send back the image to the PC. Now, several things are at work here. Several things. We have a protocol that is being used, and the protocol here happens to be HTTPS, which is the secure version of HTTP. So that's one thing that we have working there. Another thing that we have working is that we have a name. This is the name for the server. So this machine actually has a name, and the name is demo.filestash.app. But remember, whenever we are doing end-to-end communication, meaning we want a client to talk to a server or a device to talk to another device, then we need to establish an IP address. So this thing called demo.filestash.app, that name that is associated with the server, is going to be resolved or converted to an IP address that is associated with the server. So that's a key distinction to be made as you think about what is happening in this example. So on that server, there are going to be some folders. So we have a folder called view, and inside of view we have a folder called pub, and inside of pub we have a folder called example, and inside of example we have this file called mimeexplorer.png, which is this file over here that we're talking about. So once that request is made, because remember, the client is going to make a request, an HTTP request. Once that request is made and it is sent over to the server, then the server is going to locate the resource, and then it's going to send the resource back to the client in the form of a response. Now, in terms of sending that image back, remember the OSI model says that once we reach a transport layer, then we start to chop up the data. So it therefore means that this image is going to be chopped up or divided into chunks. And at the transport layer, these chunks are going to be numbered, because they need a sequence number, so that when they reach the client, they can be ordered in the correct way, so that we can make sense of the picture. That's one. Another thing that the transport layer is going to do is it's going to associate a port number with each of these chunks. And the port number for HTTP is 80. For HTTPS it's different. I don't remember what it is right now. But let's just assume that we're working with HTTP. So what it would mean is that each of these chunks would be associated with the port number 80 or the tag 80. So once these chunks reach over to the client, then the client can examine each chunk, look at the port number, see that it is 80, and know that it is supposed to send those chunks to the browser, because the browser deals with chunks that are HTTP oriented. So that's good from that perspective. So that's the transport layer. Now remember that below the transport layer, we now have the network layer. And at the network layer, we are now concerned about the IP addresses. So we are going to take the segment that has the port number, the sequence number, and the data, and we are going to add additional information to that. And what we end up with is now going to be called a packet. So what kind of additional information are we adding at the network layer? Well, we spoke about it earlier. At the network layer, we are going to be adding IP addresses. So this machine over here, this client, will put its IP address on the packet. And also, this IP address here, that is going to be converted from this name. That is the destination. That is where we want to send it. So that is also going to be attached. So we need a source IP address and the destination IP address. And this now becomes a packet that then goes down to the next layer. And at the next layer, which is the data link layer, we are now going to add on the MAC addresses. So the MAC addresses are going to be the MAC address of this machine. And at some point in time, it will also have the MAC address of this machine. Now you might be wondering, why am I saying at some point in time? And the reason for that is, at this point, this client cannot know what the MAC address of this server is going to be. So that has to be determined as the packet flows through the network from device to device until it reaches this server. Because bear in mind that this thing here is the internet, and the internet is a vast worldwide connection of devices. So the packet has to somehow move from this client, navigate the internet, which means that it's going to move from device to device to device to device to device until it is able to reach the server. So the MAC addresses of the source and the destination of the packet is going to change as we move through the internet. We will discuss that later in our example. Now, once we leave the data link layer, then what is now going to happen is that the frames, because the data link layer deal with frames, the frames are now going to be converted to bits. And these bits are then going to be pushed onto the medium by virtue of the NIC, the network interface card. And then it transmits over the wires until it reaches the destination. So from a high level point of view, it's important to understand the client-server architecture, because that is the dominant architecture that you're going to find within organizations today. But we cannot finish this lesson or this session without talking about the physical connections. So here we are now talking about the Ethernet standard. And remember, we have two types of NICs, network interface cards. We have the Ethernet oriented ones. This is an example of one such. And we also have wireless. For our conversation today, we're just going to focus on the wired one. So some things to note. There is an Ethernet port here, and this is a physical port. And remember, we're making a distinction between a physical port and a logical port. The physical port is what we find on the Ethernet NIC. Physical port, it's a slot. Whereas the logical port is what we find at layer 4 when we're talking about HTTP standards or FTP and so on. So those are going to be the numbers which are associated with each of these chunks, so that we can know what to do with these chunks when it is received. But now we are talking about the physical layer. So we have our port, our physical port. Please note that it has some pins on the inside. So it has some pins, and these are numbered from 1 to 8. And this is important because this RJ45 cable is going to connect into that port. And please note that the RJ45 cables are also numbered from pins 1 to 8. So it therefore means that pin 1 of the RJ45 cable is going to be physically connected or interface with pin 1 of the Ethernet port. And this is important because there are 4 wires or pins which are important. We have pins 1 and 2 and pins 3 and 6. And these are going to be responsible for transmitting and receiving data when we're talking about our RJ45 connection points. So pins 1 and 2 and pins 3 and 6. Now we need to understand the devices on which they transmit on and which they receive on. So for PCs, for laptops, and for routers, just going by this table that we have here, we transmit on pins 1 and 2, but we receive on pins 3 and 6. So if we are going to communicate between these two devices, then it means that this device is going to transmit on 1 and 2, and this device is also going to transmit on 1 and 2. But here's the thing. When we transmit the data, it has to be received, which means if the PC needs to communicate with the laptop, and we're using this wired connection, then the PC is going to transmit on pins 1 and 2, but when it reaches the laptop, we want the laptop to receive it on pins 3 and 6, because the laptop receives on pins 3 and 6. So here's the challenge that we have, and that's why we end up with 2 types of cables: a straight through cable and a crossover cable. If I were to take the 8 wires, have them straight out on the table, and I just connect each of these wires starting from pin 1 straight to 8 in that same fashion on both ends of the cable, then what it means is that pins 1 and 2 is going to be tied to pins 1 and 2. So let's become clear. So what that means is that pins 1 and 2 of the PC is going to be tied to pins 1 and 2 of the laptop. And if that is the case, then it means that the laptop won't be able to receive. Because what we want is pins 1 and 2 of the PC to be tied to pins 3 and 6 of the laptop. And that is why when we are doing a connection between a PC and a laptop, we don't use a straight through cable. Because if we do that, then the communication won't take place. We need to use what is called a crossover cable. And look at what happens in the crossover cable. Pins 1 and 2 from one end is going to be tied to, or it's going to be going to pins 3 and 6 on the other end. So when we have this one cable, and if we look at it from one end and we trace pins 1 and 2, when it reaches to the other end, those same wires are now going to be going into pins 3 and pin 6 slots. And that is what is meant by a crossover cable. And we need to do this so that we ensure that the transmit is going to the receive. And notice that this is occurring from both ends of the cable. So from the left hand side, so this is the PC side, the transmit 1 and 2, we want it to go to 3 and 6 of the receiving side. And from the laptop standpoint, pins 1 and 2, we want that to go to the receiving end of the PC. So in this case, using a crossover cable would work. Now, another thing to note is that we can classify devices into different families based on the pins on which they transmit and which they receive. So the PC, the laptop, and the router, those are similar devices. They are in the same family. because they both transmit on pins 1 and 2 and they receive on pins 3 and 6. On the other hand, switches, bridges, and hubs belong to the same family and they are different from routers, laptops, and PCs because a switch transmits on 3 and 6, but it receives on 1 and 2. So the implication therefore means that if I'm going to tie a laptop to a switch, I want to connect them physically. Then in that case, I'm going to use a straight through cable because I will be transmitting on pins 1 and 2, but the switch would be receiving on pins 3 and 6. So therefore, a straight through cable would work. And that's important when we're using packet tracer to connect up our devices, because we need to know, should we use a crossover cable, as in PC to laptop, or should we be using a straight through cable, as in a laptop to a switch. In the next session, we are going to be looking at a lab example, and then we tie back all of this again that we have looked at, both the OSI model and the client server architecture.